Hello Year 11, here are the answers to your 5 a day. So, in our final lesson on kinematics, we'll be looking at velocity time graphs, how to represent situations using them, and further information that we can decipher from the graph. So when a particle is moving with a constant velocity, the corresponding velocity time graph is a straight line parallel to the t-axis. When we're drawing a velocity time graph, the t-axis that shows the time is always horizontal and velocity is always the vertical axis. Here we have v graphed against t. This is a constant velocity of 8 meters per second. The time on this graph is from 0 to 4. The displacement of the particle is just the area of the rectangle, 32 meters. When a particle moves with constant acceleration, its velocity is given, you'll remember from last lesson, as v equals u plus at. This is a straight line graph with a gradient of a. So in this case here, our initial velocity is 1, our final velocity is 9, the time taken is 4 seconds. I don't actually tell you that that's seconds anywhere, or that we're measuring in meters per second, but I'm just telling you now verbally. What I can say here, the displacement of the particle is actually the area of this trapezium. So that's 1 plus 9, which is the same as saying initial velocity plus final velocity, multiplied by a half, multiplied by the distance between the parallel sides for the area of a trapezium, which is the time in this case. For positive velocities, the displacement is equal to the distance travelled, which is equal to the area under the velocity time graph. This is the case when the acceleration is variable too. I'll give you a moment to read this example question. Pause the video and have a go at drawing a velocity time graph for this. So, our velocity axis is the vertical axis. We need to give the units, like I forgot to do in the previous examples. So we're given meters per second. My maximum velocity is 8 meters per second, so that's how far my vertical axis has to go up to. My time axis is measured in seconds, goes up to 16 seconds. For the first 2 seconds, my particle is accelerating until it gets to 8 meters per second. Then travels at a constant velocity for 8 further seconds, so that's 2 plus 8 seconds, so I'm up to 10 seconds here. Then it takes 2 seconds to decelerate to 4 meters per second, and then it continues at this velocity for 4 further seconds. The acceleration between t equals 0 and t equals 2 is the gradient of this line. Remember, the gradient is the vertical difference divided by the horizontal difference. So that's 8 over 2, which is 4, or I can use my formula, v equals u plus at. v is 8, u is 0, my time is 2, my a is what I'm solving for. The acceleration between 10 and 12, same idea. I can use v equals u plus at, substitute in the values I know, and solve for a. You'll see here, I'm decelerating. It says that in the question. My line is going down, has a negative gradient, so my acceleration is -2. The total, so net is another word of saying the total displacement over the course of this journey, I work out the areas of each of the parts and add them together. So 2 times 8 divided by 2 is the area of this triangle between t equals 0 and t equals 2. 8 times 8 is the area of this rectangle. Then 2 times 4 over 2 is this small triangle here. And then 6 times 4 is this rectangle. You can split up the area under the graph however you like. Just make sure you're careful with your calculations. So now you can answer questions 1 to 7 from 22D. For each one, make sure you draw a velocity time graph to help you. And here are your answers for the first 4. And here are your answers for 5, 6, and 7. Now, this velocity time graph here shows the motion of a particle with a velocity of -8 meters per second. Remember that what that means is it's moving to the left-hand side. The shaded region represents a displacement of -32 meters. That means the particle has ended up 32 meters to the left of where it started. As you will have seen in methods with calculus, regions above the t-axis or x-axis in methods have a positive signed area. Regions below the axis have a negative signed area. So we need to be aware of this difference when we're calculating total areas. In this example, our particle is moving in a straight line, initial velocity of 10 meters per second, constant acceleration of -2 meters per second squared. So I'm not told what time I need to draw my graph up to, but I do know that the line will pass through the t-axis. For every second, my velocity decreases by 2 meters per second. So when I get to 5 seconds, my velocity will be 0, and then I will continue into the negative velocity area under the t-axis here. So the motion of the particle during the first 8 seconds. Between t equals 0, t equals 5, the velocity is positive. It's above the t-axis. Because the velocity is positive, that means the particle is moving to the right. At t equals 5, the particle's velocity is 0. That means it's stationary. From t equals 5 to t equals 8, the particle has negative velocity. That means it's moving to the left. To find the total distance travelled in the first 8 seconds, I need to work out the two areas separately. So I can use just the triangle area formula. I've got 5 times 10 times a half, and I've got 3 times 6 times a half. Notice here that I have to calculate what my velocity is when t equals 8. I can use that just by using the equation of this line. So if I add those two together, I get my distance travelled. If I were to integrate, which I could do, it's a bit overkill when the line is straight, I would need to integrate between 0 and 5 and between 5 and 8. Remember that if I were integrating, this would be a negative area. So I would need to subtract this area, or instead of integrating between 5 and 8, integrate between 8 and 5 in order to make this area value positive. The displacement after the first 8 seconds of motion is how far away the particle is from where it started. In this case, I find the signed area, so this is negative because it travelled out this far, 25 meters, and then it starts moving back again by 9 meters. So its displacement is 16 meters. So now you can answer questions 8 to 11. Make sure you mark your work. and let me know if you have any questions. Thank you.